today I am here to talk to you about how soon can we roll that out? The number one question that our stakeholders ask whenever we come to them with a feature. So it's Agile data-driven design and development for high ROI chatbots. So before I can really get into that, you should probably know a little bit about me. I've been a machine learning engineer at T-Mobile since 2017. My name is Heather Nolis, and I was a founding member of our T-Mobile AI team. And so we do not just chatbots, but we do a lot of agent-facing AI as well. And so our scope is really broad. And I used to really imagine myself getting a PhD in molecular neuropharmacology. But while I was doing research in neuroscience, I finished the end of a very long project, and my PI asked me to now hand off my data to an analytics team. And being somebody who loves numbers and also loves knowing every detail of every project, I just couldn't stand to actually hand away my data. So I had a bit of a breakdown and was like, I'm going to go away and learn how to do whatever analysis you think I need. And then I fell in love with coding. I fell in love with machine learning and data science. And so that's how I ended up here. And I'm incredibly active on Twitter. So if you have any questions about anything, you can always check me out. It's at HeatherCliss. And so, like I mentioned, the team that I am on is AI at T-Mobile, and our primary scope is customer care. So this means that every time that you have a problem and you are a T-Mobile customer and you have to message us on Facebook, Twitter, via your app, if you have to call us, we want to be using artificial intelligence to make those interactions as seamless and beautiful as possible for you. And that's where we want the bulk of our AI power to be applied, is in solving these customer problems that are pretty complex. And so we are a fully stacked team for real-time AI, and this means that we have all of the data people that you need to analyze, improve feasibility of your concepts. We have all of these software engineers that you need to actually productionalize and support something that's running in production. And then we also have our product and delivery managers, making sure that our ideas are business relevant, that they are actually fitting use case, that they will deliver real value, and that we can deliver on time. So the AI team has everything inside of it. It's fully stacked, fully encompassed, that you need from the second that you have an idea to all the way like your product needs to retire because it's been grooving in production for so long, is kind of our concept. And how chatbots fit into this vision is a little bit complicated because 30% of our customers want self-service. 30% of our customers, and growing, want self-service. They want to talk to a bot. And so we are building our bots for customers who want bots. But T-Mobile has a slogan where we say we want to be famous for care. Our customers are always first. So the bots that we're building, we want to make sure that they are being held accountable to the same metrics that our human agents are being held accountable to, and that every experience that customers are having with our bots is just as delightful as one that they would be having with a person. Otherwise, it's not worth it for us to be building. And so our real goal is no clippies. We don't want to be an annoying virtual assistant that's in your face. We want it to be self-service for people who actually want self-service. And so this next section is how we refine, and it's how we decide what we are actually going to build next. How do you take something from an idea and build it out into an actual feature that can be executed on by engineers? And so this is true for any AI project, but chatbots also, that you need a few things. You need a clear objective. Computer science and computers, they aren't very smart. They really need simple tasks, and you have to know exactly what KPI you're trying to solve for, because otherwise you run the risk of standing up beautiful technology that doesn't actually solve a business objective. So the first thing that you have to have is an incredibly clear objective. What are you actually trying to do here? And preferably you have lots of data around that objective to support it, and it's been thoroughly researched. And then the core team that needs to pop up the second that you have an idea for a feature is you need product people, a role of product, who are advocating for the value that's brought to the business and the stakeholders by your project. You also need a designer who is ensuring that your solutions are actually useful for the customers. And so they are there to advocate for the customers. And then you need a data scientist or an ML engineer to make sure the things that you're talking about are feasible and the tech is right fit. So that way it's not somebody getting excited about something that they've read online that might be overblown as far as what the production capabilities can be. And so you really need all three of these people involved from the second that you have an idea for a feature to ensure that it's bringing value across all areas. You can't just have a product person saying this would be really useful for the business. We also need design saying it's useful for customers, and data scientists or engineers saying this is something we can actually do. And the part that's most important to me is that the design process has to be iterative. And so I'll go through an example of all of the work it takes our conversation designer to even get to the point where we can start writing JIRA tickets, we can start putting things in a backlog for engineers to act on. So this is an example. We have a meeting every Monday where we review all of the survey results that we have gotten for our bot for the previous week, and we also review the conversations attached to it. And lots of ideas for features come out of these review sessions. And so let's say we have an idea. Let's add a feature. The first thing that will happen is me, data scientist, machine learning engineer, is going to go out and we're going to pull data. And we're going to make sure that we actually get enough traffic to justify building it. Again, if we build a beautiful technology that's not solving a problem that our customers are having, people aren't actually talking about it, we aren't helping anybody out. We're just making ourselves feel good because tech is fun to build. So we pull the data, we ensure that the traffic is sufficient, and then we pass a high quality representative sample of what people are asking about this topic to our designer. And that's so that way she can analyze the data and understand exactly what experience is going to be the best fit for the majority of our customers who are coming in. And so the designer will analyze that data and they will create an initial design, which will pass back to me. And I review it. I review it for making sure that the intents are feasible, that the natural language that is necessary there is distinct enough that I think we can actually pull it off. And that if we can't, I call out where I think there will be high areas of conflict. And so we iterate there to make sure that she's not asking for the moon and I can't give her the moon. And once we get consensus, then she hands that to our product person and she says, hey, this is what I'm looking at. That's product stance to provide feedback. Say, hey, you guys designed this. It's not bringing value to the business. Or I think it would be better for the business and our stakeholders if we did X, Y, and Z instead. They have an entire iteration loop. And then we take it to engineering who says, okay, are these real-time APIs available? Can I actually build this the way that you designed it? Or did you ask for the moon? And so if you notice in this list of our data-driven chatbot features, product doesn't come in until 2/3 of the way down. And it's because the conversation designer and your data scientist, we are sitting and we are looking at conversations every single day. We can report up in aggregate, but we can also just have a higher pulse on what's actually happening. So if we want to say that we're listening to our customers, then we need to be listening to the people reviewing the conversations our customers are having. So our data team is just constantly suggesting features to the product team, and then the product team is constantly prioritizing those features. And so we have at least one engineer per sprint dedicated to helping us hammer out the features that we have listed there that we have decided are important. And that's like a trust relationship between product and the data team that is really essential to us refining our work and making sure that the experience we're going to deliver is good. And you say, okay, but that seems like really horrifying. It would be much easier if a designer could sit down and in one shot pump something out and then we put it into production. That's more like traditional software development. And so you might be looking at all of those steps that I listed and saying, why isn't this easier? It's 2021. And my response to that is that the lift required to build models is getting lower constantly. So you're absolutely true. Like in that sense, AI is getting easier. However, the expertise required to implement these systems that actually are addressing customer problems and to design good products around them, the complexity of these is only increasing. Our world is getting more complex. We have more data. We have more products that we want to build. We have higher ambitions and expectations for ourselves, and our customers have higher needs. And so while maybe modeling is becoming an easier piece of artificial intelligence, building good AI products and the design work that has to be done around that is becoming more difficult and more complex. And this is not saying that everybody should go out and become a data scientist. It's just saying that you should understand the data science lifecycle when you're going to build a product that includes data, which means you can't just list out all the intents that you imagine in your brain and have a data scientist do that. You actually need to have a back and forth iteration so they can prove it's feasible. And then once you get a team started, there's the question of how do you grow? How do you decide what sorts of features to prioritize next? How do you decide what sort of team that you're going to be? And so when we were in this position, this is kind of what we were thinking about. There's a team structure here where you could grow incredibly wide. That would be having lots of intents, lots of FAQs, very shallow flows, but we could get a good spread of the conversations that are coming into T-Mobile's customer care. Or you could grow deep, where you go down a very long, complex flow with lots of intricacies, but really only focused on a few use cases. And then we knew that we wanted to be fast at whatever we were choosing to do. And for a while, I think that we felt like we had to make a choice here. Are we going to try and be fast, wide, or deep? But what we've discovered is that with good design, organization, and release structure, you can do all three of those things at once. And so this is how we organize that style to do all three of these types of development at once. So we have 3 teams, 2 backlogs, and we all support 1 product. So we have 3 agile teams that really focus on 3 development styles. And for the sake of this talk, we're going to call them team width, team depth, and team speed. So team width is a completely fully stacked agile team that's focused on increasing the variety of questions our bot can answer. So a lot of this is wayfinding, simple, giving people a landing page, directing people to more information, or use cases that can be contained within a few turns, but stuff that can generally be completed at least within 1 sprint. And then we have team depth. And team depth are a team that will go offline and create beautiful, complex, rich flows that with fully fleshed out customer experiences that are fully contained use cases that might take months to develop on and test accurately. And then we have team speed. And team speed it's your data scientist, it is your conversation designer, and they are constantly analyzing the data from production models and production conversations. This team owns designing the experiences that go out. It owns tuning all of the existing intents and entities that happen, and then also updating bot responses and quick, fast backlog items. So using these 3 different teams, we were able to kind of look at the ways that we were considering growing and actually split that out and say, we have a team focused on spreading wide, we have a team focused on driving deep, and we have a team focused on quick wins. And one thing that we found that's incredibly important when you're moving this quickly is to have incredibly clear division of work for every single feature. Our speed team, we do at least weekly model releases. And so when you have only 1 week to develop and craft multiple flows that you're going to release, even if they are just a few turns, you might have up to 3 people working simultaneously on a feature. So that's 1 person whose job it is to craft the intents and entities. You have 1 person who is building the stories, and then you might have 1 person doing a really intricate action serve integration or writing a custom action that requires a lot of effort. And these people have to be kept absolutely in sync. We have tried saying, what if engineering finishes first? And if engineering finishes first, you run a big risk, because with natural language, there's always the chance that things don't go as planned, or with any sort of modeling. There's always a chance that things don't go as planned, that your data doesn't look like you thought, and despite all of your planning, it's not quite true. And so you might have to, if engineering finishes first, and then NLU comes into one of these hiccups, there might be some design iteration that has to happen, and then engineering has to update their work, and it becomes sticky and hard to keep track of what's where. And then if natural languages finishes first, the risk that you run is that engineering time could be allocated to a higher priority feature, and then the design can drift over time. So by the time that engineering resources are back on this item, we look at the design and it's no longer relevant for the bot that we have in market. Maybe the intent isn't even useful, so we have to redo that. And so it just creates a ton of rework if you don't keep these people incredibly in line. And then the next thing is that when you have this many people touching a bot, you really need to quintuple check the fidelity to your actual design. Most conversation designers don't know how to go into code and check this, and so they are operating on a trust system with us, developers. And so for us, what this means is that bot tuners and engineers are looking at the design documents while we are creating any new intent in any flow very explicitly. Our product people are looking at these while they validate any work, so stories cannot be accepted unless they exactly match the design. Stakeholders are checking the design when testing, and they're making sure that every link is correct. And I mention this because some things that people have been surprised our conversation designer cares about are correct emoji or even including emoji. The emoji weren't optional. They were part of the design. They're really important. New lines being in the correct place. So where do you start a new line? Because that really changes the experience for somebody reading it on their phone. And then also incredibly precise wording, including punctuation. So these are all things that engineers on our team have been shocked, and they thought that there might be a little bit more leeway in how they're implemented. But if you aren't incredibly strict about adhering to the design that you've created, you're diluting the power of the person that you are paying to design. And if you're going to let engineers change it at the last minute, why pay a person to design when you could just have an engineer wing it? And so we care a lot about the fidelity to design and doing these quadruple checks. And so I've talked about how our teams are stacked, the way that we divide up our work into multiple tickets with people working on it. And so I want to talk about how all of that rolls up into being code that is released in production. And we release 2 times a week on average. I looked at our release calendar last night, and we have done over 50 releases in the first half of 2021. So we are a pretty fast team. And so a lot of that is the incremental model releases that the fast team releases, but it's also larger features. And so I'll go into how we kind of split up that work. When I think today, if I was going to go, I'm going to make my bot better today. There are so many things that I could do to make the bot better. So this is just a sample of work our bot might need. It's creating new features like cool pop-outs and UI enhancements. It might be small wayfinding flows for things that are really important, tuning existing intents, investigating major KPI trends, actually creating long, deep flows, writing custom actions that pull in new data. And so there's a huge variety in this type of work. Some of these items are so simple that they can skip this robust Agile engineering grooming process that takes hours out of developers' day. And so our idea here was for items that are so simple, they can skip that robust Agile engineering grooming process, like updating a link, updating a bot response that will take an engineer 45 seconds. Let's give those items their own backlog. And so we have 2 work streams and 2 backlogs. I'll talk about the right side first because it's what's slightly different. And the left side is mostly traditional engineering. So by discussing what's different first, I hope that the other comes into sharper focus. So our incremental model releases, they are owned by the data and design team. We have a completely separate backlog. And before each sprint, we basically show what we want to be completed to our product people, and they give us sign off. And so there is a check from product, but we really own that. We guarantee weekly releases. So we've switched the days that we're releasing a few times, so either Tuesday or Thursday, there will be updates, no matter what. And these type of updates are tuning the existing entities and flows, updating bot response content, and any quick like V1 wayfinding that we can do. So like a new feature that we might have a really long flow, but we won't be able to get to for a few weeks. At least for now, we can do pop somebody to a page, give them a small experience. So it's items with low external dependencies. So not complex action server stuff, no talking to other teams, no new data from new APIs, nothing that would make it require formal grooming. And then we also have traditional releases, and that backlog is owned by the product team, though the data and design team submits items into it constantly. They release when features are done, they do these longer, complex flows, brand new features, things that require complex integrations with other teams, or anything that is so controversial it would require an engineering discussion of more than about 30 seconds. And so by having these 2 different work streams, these 2 different backlogs, and these 2 different release cadences, we are able to be incredibly fast. What we found before is that something like updating a link in a bot and a bot response might be very low priority for a product person who really wants their engineers to be focused on features, but that's actually really important to the customer experience. So we have 2 different methods of prioritizing work here, and that's what makes this very nice. You can say, okay, that was a lot. What sort of impact are you actually having on your company? And so before I did that, I went to just summarize kind of what I've said here. So an organizational snapshot of the very complex Rube Goldberg machine that is the customer assist team on AI at T-Mobile. We have 3 teams, one focused on shallow spread, quick experiences, one focused on very deep, rich flows, and one data and design team that's focused on fast wins and filling those other 2 backlogs. We have 2 backlogs, One is for iterative releases. That's run by the data and design team, and we release every single week, no matter what. There are always improvements that we can be making that are very quick. And then there are traditional releases, and those are run by the product team, and those are the more meatier, substantial style releases. We have up to 3 people working on features. That would be one on NLU, one on stories, and one on custom engineering integration. And everything starts with iterative design. Every single change. It's completely non-negotiable. But that seems really hard. Like, that's really hard, that's really complicated, and I've talked a lot about how hard it is to keep everybody in lockstep, churning towards the same end goal with high fidelity. But in my opinion, when I look at the numbers that our team has been able to do since we've been in market, to me, that proves that we are onto something here, that all of this effort that we put into optimizing an incredibly high efficient team with 3 legs and 2 backlogs and 1 product has been worth it for us. And so a little bit of that story can be told in these metrics, which is our time to market, or our time in market has been about 3 quarters. We contain 7% of conversations, meaning that 7% of people who come into messaging, we are able to end up helping. That's partially a reflection of the number of experiences we offer, but it's also a reflection of the percentage of people who want to engage with self-service. So I think we cover about 30% of all conversations, and then if about 30% of those people want to opt into self-service, 7% seems like a reasonable amount number for us to be successful on. And we have handled, since launching, over $5.1 million worth of conversations for T-Mobile. And so that's $5.1 million of conversations that are incredibly rote memorization, that our experts sitting in call centers don't like to handle because they are incredibly easy and automated. And so that's $5.1 million that we've been able to kind of give back to T-Mobile by taking some of this irritating work away from our experts. And that turns out to be a return on investment that's over 750%. And this blows my mind because I've been working on T-Mobile AI products for 4 years, and I've never seen an ROI like that. AI products are incredibly expensive. Data scientists are expensive, machine learning engineers are expensive, and it's very easy to get distracted by the technology and invest in solutions that have more technology than they are bringing business value. So the fact that we are able to have a 750% return on investment makes my whole heart shine, and to me speaks to the incredible efficiency of this complicated system that we've come up with for managing our work and for scaling effectively. And because of this, we also have what I call a selling problem. We have people coming to us all the time because they are excited by the success of our chatbot, and they want us to build a chatbot for them as well. So we have to kind of start turning away work and being very selective in what we're choosing to take on, because people get so excited when they hear about the value that we've been able to bring to various teams. And so we have at least 2 bots in our future pipeline, but I imagine that we will end up with many, many, many more, just based on the excitement that exists right now about our product. And so that is the bulk of what I have to talk about today. Again, if you have any questions, you can ask me right now, because Q&A is my favorite thing ever. And if you are thinking of them later, then you can also ask me on Twitter. I'm available pretty much all the time.